We're going to work today on lesson 612, division of decimals by decimals. So we're going to create equivalent problems to help you solve division problems involving decimal dividends. We're going to perform operations with multi-digit whole numbers, excuse me, and with decimals to the hundredths. We're going to apply and extend previous understandings of multiplication and division to multiply and divide fractions. So to start off with, we're going to do our math warm-up here. So we have the first one. You see it's a number multiplied by 10 to the second equals 800. So when I look at this one, I see here that I have two zeros, and I see my exponent 2 for power of 10. So I know I could simply make it 18, and then that I added the two zeros. Let's look at the next one. This one's divided by 10 to the second. So remember, whenever you're dividing by power of 10, you're moving your decimal to the left. So we actually would want to think about that. What would we do here? So we're not multiplying, we'd actually be smaller, right? And so because we would have moved my decimal to the left, I'm going to move it back to the right here. And so I'm going to start with 739 because I know when I divide, my decimal goes to the left. And in this case, it went between the 7 and the 3. And our last one on here, multiplied by 10 to the fourth. So when I look here, I can see my exponent 4. And I see I have 4 zeros. So I know that it would be 55 times 10 to the fourth, and they just added 4 zeros. Okay, so I want you to look at these, pause the video, go ahead and try these on your own, and then come back. Okay, hopefully you've had a chance to look at these now and try them. So they're a little bit trickier. So I see I'm multiplying by 10 to the third. I only see 1 0, so I know that I had to have had a decimal in there somewhere. And I know when I multiply by powers of 10, I go to the right. So 1, 2, 3. So I would have started with 55 hundredths or 550 thousandths. The next one, I'm dividing by a power of 10, and it's to the 10 second power. And I know when I do that, dividing, my decimal started over here. Or sorry, I just did that backwards. It went to the left, so it would actually have started as 3,075. Because we know when we divide by powers of 10, our decimal is going to the left, and it says 2 spots, and it ended up over here, which tells me that it started at 5. And then the last one here, I see I'm multiplying by 10 squared, or 10 to the second power. I do not see any zeros, so I know somewhere I must have had a decimal, and I know that my decimal makes 2 jumps to the right, so I could put decimal 0 here, which would tell me that it started there, so I would have 84 and 11 hundredths. And for our vocabulary, an equivalent problem. So we've talked about equivalent fractions. An equivalent problem is a division problem solved by writing an equivalent expression. For example, we could solve 35 6/10 divided by 5/10. You may solve the equation by doing 356 divided by 5. And that's what we're going to learn how to do today. So an equivalent problem. Now, I want you to open the calculator on your computer, or if you have a calculator in your hands or on your phone or tablet, that's fine too. But you're going to use a calculator to solve these problems. Record your number sentence for each problem. So I want you to take a minute. I want you to put each of those in the calculator and solve. So go ahead and pause the video and do that. Okay, so you're back. And so I'm going to pull up my calculator here, and we are going to see if we get the same thing. So my first one, I have 2/10 divided by 100, and I got 20. So I'm going to put my 20 underneath there. So you should have these written down somewhere. Let's look at our next one there. I'm doing, clear it out. I'm doing 2 divided by 1/10, and I still got 20. I'm going to look at, and I know the next one, 20 divided by 1 is 20. This one I can do without a calculator. I could mark the common zeros off, and I know it's 20 divided by 1 is 20. And And here I can mark off my common zeros because I'm dividing multiples of 10, and it becomes 20 divided by 1, which is 20. So what do we notice there? Is there any surprises? When I look at that and I see 20 across the board, I see that I have a lot of the same digits. I'm only working with 0, 1, and 2, but it is a little surprising to me that they all came out to be 20. So let's explore why that is the case. So we have the different number sentences here, right? And that we just solved. So we could think about those. And if you look, you might start to notice that they all, again, look very similar. You came up with the same quotient. So these are going to be what we call equivalent problems. So each of these got the same quotient. They use the same type of digits, so 0, 1, and 2. It's just all about the placement of the decimals in the problems to make them equivalent problems. And we will work on that. So is it surprising to see that the quotient for the first two problems is greater than the dividend? So if we look here, the quotient is the answer to division. And then look at the first two problems we had. The dividend is here, and the quotient is larger than the dividend for both of them. Do you find that surprising? One thing to think about is when you divide, you're splitting it into more groups. So one way to interpret a division problem is to think how many of the divisor are in the dividend. So when you think about it that way, you're thinking about how many groups or how many of these divisors fit into that number. So how many of these fit into our dividend? So when you think about that way, again, like with any division, you're splitting it up, right? If you were to take candy, a pack of candy, or a bag of chips, or a box of cookies, and split it, divide it up among your friends, you know that you're going to have some more, but they're going to be smaller groups. So for example, how many tenths are in 2? Well, we can see here that there are 20 based on our division. So does answering this question help explain why 2 divided by 1/10 equals 20? So what we're saying here is we want to think about this, like how many tenths are in here? And we know tenths are smaller than 1, so think about that when you divide the 2, right? You're splitting it up. There's 10 tenths and 1 whole, and you have 2 of those. So each tenth has 10 hundredths, so there are 2 times 10, or 20 hundredths, and 2 tenths. So examine the dividend and divisor in each problem. So let's see how do they change. So let's look at the dividend here, 2 tenths, and then I see 1 hundredths, right? So I went from tenths to hundredths here. Here I went from the ones to the tenths. Here I went from tens to ones, hundreds to tens, thousands to the hundreds place. So do you see how each time we're going back a place value? So our dividend each time is going up 1 place value. So we went from tenths, ones, tens, hundreds, thousands. And then when we look over here at the divisors, we go from hundredths, tenths, ones, tenths, tens, and the hundreds. So hopefully you notice that pattern there, that this is what we would call an equivalent problem, because both the dividend and divisor are changed. They both go up a place value on the chart. So again, we just looked at how the divisors change there. Each time they're moving up a place to the next place value, right? They're getting greater by 1 place value every time, or 10 times greater. From problem to problem, the dividend and the divisor were both changed the same way. They were each multiplied by 10, or like we said, changed place value. Making the same change to both the dividend and the divisor did not change the quotient. So that's the key thing. If you change the dividend and the divisor by moving them up a place value or moving them back a place value, that will not change your quotient. If you add in extra numbers other than 0, then it would change it, right? So making the same change to both the dividend and divisor did not change the quotient. Every fraction can be interpreted as a division problem and vice versa. So when I see 5 divided by 8, I can also write that as 5/8. So how could we write 2 divided by 1/10 as a fraction? So let's think about that. Okay, so hopefully you've had a moment to think about that there. So if I wanted to write 2 and 1/10 as a 2 divided by 1/10 as a fraction, we could rewrite it as 2 divided by 1/10, right? We obviously can't put 2 over 1/10 and have a fraction like that, but I could say 2 divided by 1/10. So we could write 20 divided by 1 as a fraction because we couldn't do the other way. So what I could do is, this really doesn't, you don't put a decimal with a fraction, so we have to make an equivalent problem there. So what I could do is change it up, move it up a place value, so add a 0 like they did here. And here, instead of adding a 0, we actually want to go to the left and change our place value to 1. So we want to be 10 times greater. Now, 20 divided by 1 is the same thing as 2 divided by 1/10. So again, you can't really write 1/10 as a decimal for a denominator. But what you could do is create an equivalent problem by jumping them both place value, moving them both up a place value. So these two fractions are equivalent fractions that have the same value. The corresponding division problems are equivalent problems that have the same answer. So again, you can see here, they just added a 0. They moved it up a place value, or 10 times greater. Same thing here. We moved it up from the 10ths place to the 1s place, kept the same digit, and it makes it where you can divide it. So creating an equivalent problem can be useful when solving decimal division problems. Today you apply what you know about equivalent fractions to generate equivalent problems. So what rule do we already know for generating equivalent fractions? When we write a fraction as a division problem, where do we write the numerator and the denominator? So remember, equivalent fractions, when you change the denominator, you must change the numerator as well. Okay, that's really important that we do that. So that's the same thing when we're making equivalent problems for dividing. We can't just change the dividend and not change the divisor. We have to make the same change to both, just like we do with equivalent fractions. So how can we use the rule of generating equivalent fractions to generate equivalent problems? Like we just said there, right? That we need to make the change to both the dividend and the divisor. So you already know strategies for solving decimal division problems with whole number divisors. One way to solve problems with the decimal divisors is by thinking about equivalent problems that have the whole number divisors. So I want you to pause the video, and I want you on your marker board or paper, I want you to think about how you could write this problem as an equivalent problem. So pause now. Okay, hopefully you've taken the time to try this. If you remember the rule we said for equivalent problems there, we need to change both the dividend and the divisor. So I could think about this. I could make 3, I could put it in the tens and make it 30. And then I would want to take my 2/10 and bump it into the 1s place and make it 2. And I know that 30 divided by 2 is 15. So let's check our decimal with a calculator. It should get the exact same quotient. So 3 divided by 2/10, it's 15. So you can see there we get the exact same problem. Now at this point, you want to not use your calculator on these decimal problems because you want to be using the strategy. So we did that in the beginning so we could study the pattern. So we'll make that clear. I was showing you there that 3 divided by 2/10 is the same thing on the calculator as my equivalent problem, 30 divided by 2. But please don't continue to use a calculator unless you're prompted to. So how do we multiply 2/10 by 10? Okay, so and what else do we need to do to make our new problem an equivalent problem? So when we multiply 2/10 by 2, we simply move up a place value and it becomes 2. What is 3 times 10? We know that is 30. And that tells us how we change to our equivalent problem. So we know that we can multiply 3 by 10 or bump it up one place value. And we know the 2/10, we could bump it up one place value as we did and put it in the ones place. And then we get 15. And we know that 30 divided by 2, we've already looked at this, that it is 15. And why are the answers the same? So think about that. We created equivalent problems. We changed the dividend and the divisor. Same thing when you get equivalent fractions. If you change the dividend and the divisor and you follow the same rule for both, then you will get an equivalent or equal fraction. In this case, an equal prop for division. So how many groups of 2/10 are in 3? Well, based on our quotient and our division, we know there are 15 groups of 2/10 and 3. So if I had 3 packages of something and I wanted to split it into 2/10 for, I would know that I could do that 15 times. So how about use an equivalent problem to solve 8 divided by 2/100? So this one's a little different. So let's look at this one. Now I still want to try to get it to whole number division, and I see here that I would have to move my 2 up 2 places, so I'd have to multiply it by 100, and so that would become 2. And since I moved that 2 place values up, I want to move this guy up 2 place values, or multiply it by 100, and I would get 800 divided by 2, which equals 400. So again, I don't want you to continue to use a calculator, but I'm going to model for you here with the calculator to show you that when we did our equivalent problem there, we got the exact same answer. So 8 divided by 2/10 equals 400. So again, what we did here, I know that I want to make my divisor into a whole number. And in order to do that, I had to go up 2 place values, or simply multiply times 100. And whatever I do to the divisor, I have to do to the dividend. So I knew I had to do 8 times 100. So would it help to create an equivalent problem by multiplying 8 and 2/10 by 10? Why or why not? So we just looked at that. And if I was to do that, here's what would happen. I would get 80 divided by 2/10. The problem with that is it's not really helping me because I still have to deal with the decimal situation, right? And so doing 80 divided by 2/10 doesn't help if I multiply by 10. That's why I'm multiplying by, in this case, 100, because I want my divisor to be a whole number if possible. What makes 800 divided by 2 easier to solve than 80 divided by 2/10? Well, simply eliminating that decimal and its whole number division. So the point is to create equivalent problems with whole number divisors so you can apply the division strategies you already know. So the whole idea is to take those decimal things, make them less intimidating, make them easier for you to do quicker math with them. Okay. So let's look at these two. So I want you to try to write these as equivalent problems and solve on your own. So pause the video and try these. Okay, hopefully you've had a chance to try. And so I want you to see if we get the same thing here. So first I'm looking at my divisor. I know I need to bump up 1 place value or multiply by 10, and that gets me 7. So I got to do the same here. And so I'm going to actually go this way, and I'm going to get 42. And actually, hold on just a second. I did that wrong. So let's look at that one again. Let me erase all this here. Okay, let's do that again. This one, I know that I need to bump it up 1 place value into the ones place, so that would become 7. Here I have a decimal, so I need to bump it up 1 place value, and I get 42, which should be 6. So let's check that and see how, if I got that one. That one was a little bit different. So let's make sure. Yes. Okay, so you had to make one jump with both of those, or move them up 1 place value. So 4 and 2/10, I bumped up the 2 into the ones place, bumped the 4 over, or multiply 4.2 times 10, and then multiply 7/10 by 10, and I get an equivalent problem. So look at this one here. I have 2 that I have to make a difference with, right? And so I got to multiply this by 100 to get it over into the ones place. So I'm going to multiply by 100, which gives me 3. And I'm actually putting a multiplication symbol there. That should be division. And then so I got to multiply 3 and 9/10 times 100, or move it up 2 place values, and then I get 390. And so then I could do 39 divided by 3, and then add my 0. And I know it can go in 10 times, and I get 30. I have 9 left over. I know it can go in 3 more. So I end up with a quotient of 13. Okay, so the goal is to first look at your divisor, make your divisor a whole number. In this case, I see that I had to move up 2 place values or multiply by 100. So then I had to move up 2 place values or multiply this by 100. And when I multiply 3 9ths by 100, or 10 to the second power, I move my decimal to the right, and I end up with 390. So always look at the divisor first. That will tell you the changes that you need to make. So what should we multiply the dividend divisor by to make an equivalent problem, and why? So let's look at this one. I can see here that I already have a whole number, but I have 1 over here in the tens place. So I'm going to multiply that by 10 because I only need to move the 3 over 1 place value to the left. But then when I look at the dividend, if I only move over 1 place, that's not going to work, is it? Because what will happen is then I'll still have 46 8/10. So I actually have to multiply by 10 to the second power, and I would have to do the same here. So in this case, I see in the dividend, when I move the divisor, I looked at that first, I only have to move 1 place value. But whenever I look over here, I have 2 digits that I need to move out of the decimal side into the whole numbers, so I can multiply by 10 to the second. So then I end up with 468 divided by 13. And again, it's equivalent because I made the same change on both sides. I multiplied them both by 10 to the second or by 100. So this problem's different from the problems you just saw because the dividend is still a decimal, right? And so you could either change it all the way over, or you could do 46 8/10 divided by 13. But that would be a little more confusing. So remember the method of solving division problems with decimal dividends. Make an estimate. Solve the problem if the dividends were a whole number. Use the estimate to place the decimal point. So I could also go back up here, and we could do that a little bit differently. So let's look here. I could take the same problem and I could rewrite it, and I know that I want to multiply this by 10 to make my divisor 13. And let's say I go ahead and just multiply this by 10, and I end up with 46 8/10. I could do the division still. And when I divide that out, I get my answer. And then I look at an estimate. So you want to go ahead and divide that. And then look at our estimate. Let's see, 468 divided by 13. I think I could do maybe 50 divided by 10 because they're both close and they're multiples there. So I know my answer should be somewhere around 5, and that should help me understand when I place my decimal when I do that. And so you could divide that out that way to see as well. And so if we look at our quotient up here, we should end up with about the same thing. So equivalent problem for 46 8/10 divided by 13. You could estimate as 46 divided by 10 and get 4.6, or like we said, close to 5. Divide as if 46 8/10 were a whole number, and you get about 36. But then you have to place the decimal. We know our estimate was around 4, between 4 and 5, and we find we have 36, our decimal would actually go between the 3 and the 6 because that still keeps it in the ones place. If I put it after the 36 or before, that would change and not be reasonable compared to my estimate. So let's look at this first problem together. 2 79 and 9 tenths. So we want to write an equivalent problem. So I can see here I'm going to have to jump one place value or multiply by 10. So we're going to multiply this one by 10 as well, which means I move my decimal one place to the right. And then I'm going to divide it by 9. Okay. We don't know the answer yet. That's just the equivalent problem. So now I got to make an estimate. Well, if I take out the whole numbers and I look at it, I see I have 279 divided by 9. I could say 280 because that's pretty close, divided by 10. And I know that if I mark off these zeros here, I get about 28. So I know my answer should be around 28 or in the tens, not in the hundreds or anything like that. So now let's go ahead and write the equivalent problem out again. So 27 9 tenths divided by 9. And we need to actually do the division. So I'll do this one with you. And ignore that decimal to the end. So let's see, 27. I know 3 times 9 is 27, and I could add a 0. And that gets me at 270. When I subtract, I get 9. And I know 9 times 1 is 9. And I get 31. So I put 31 here. And look at my estimate. I said my estimate should be around 28. And so I ended up with 31. So where would I place the decimal there? I could say 31 decimal 0. Or I could simply just put 31. Because we know 31, our decimal, if we put it between the 3 and the 1, that wouldn't make sense because our estimate was about 28. Oh, and one mistake I guess I made there was on the estimate. So let's go back. I think I made a mistake there. I forgot that we still needed to take into account that we had a decimal there. So it should be actually 3 1/10. So my mistake on that. So it should actually be 3 1/10 because I forgot to put in the decimal. I forgot about this up here. And so we had to go back and add that in because it was in the tenths place. Okay, so let's look at the example they gave there. So then they said 28 divided by 10, and they got 2.8, and that's where I made my mistake. I did 280. We could have actually just done 28 there. It's 27 9 tenths when you do your equivalent problem. So the mistake that I made there, I ignored the decimal. But you can see here 27 9 tenths becomes pretty close to 28, and they did 28 divided by 10. Or you could have even done 30 divided by 10, and then you need to place your decimal. So pause the video. I want you to try this problem on your own. Again, you're making your equivalent problem first, then do your estimate. Hopefully you've had a chance to try that. And so check your work against what we have here. So you have 8,540. So you can see here they needed to make this into 14, so they know they had to bump up 2 place values, remove the decimal 2 places, so they got 14. Here they did the same thing. They were able to move it 2 places. And they said 8,500 divided by 10. Pretty easy to do, and you get 850. And again, you want your estimate to be where you could do mental math for that part. You don't want it to be too high. And so then they did 8,540 divided by 14, and they got 610. And you can see there's no decimal there because whenever we changed our equivalent problem, the decimals were taken away. Okay, so we'll turn to page 228 in your math journal. And you're going to work on your math boxes.